guys, in this tutorial we're going to be talking about a dilution formula. So technically the dilution formula is used to decrease the concentration or dilute a stock or a concentrated solution. So suppose you buy a concentrated orange juice or a lemon juice. What do you do in that case to make it drinkable? Well, I don't know about you guys, but I add water in there. So technically anytime you have to dilute something, you have to add water. Now, how much water you need to add in order to get to a particular concentration, that can be determined by using the dilution formula. So the dilution formula is going to be the concentration of the stock solution times the volume of the stock solution equals to the concentration of the diluted solution times the volume of the total diluted solution. So C1 V1 equals C2 V2. So technically you want to make sure you know the left side is going to be your stock solution and your right side is going to be your diluted solution. In addition to that, you want to make sure you know that V2 is going to be the total volume. And what does that really mean? So suppose you starting out with 50 milliliters of stock solution and then you add 50 milliliters of water, then your total volume in that case of the diluted solution is going to be 100 milliliters. So that's what this refers to. That's going to be your total volume, not just the volume of the water added in that particular case. Okay, so as long as in a given question you're able to identify what your stock concentration and volume is and what your diluted solution concentration or the volume needs to be, you can easily do these problems. So let me go ahead and do a couple of these problems so that you can see how to use this formula. Now, it's easy to make a dilute solution from a concentrated solution, but it's not that easy to go backward. Yes, based on the calculations you can do that, but practically it's not that easy. You have to actually get rid of water, and the only way you can get rid of water is by evaporating the water or by boiling off some water. But if you're going from concentrated to dilute, all you really got to do is just add an appropriate amount of water and you have your diluted concentration. So let's look at this question here. So it says a solution is prepared by adding 100 milliliters of water to 20 milliliters of 0.5 molar stock solution of NaCl. So you want to be able to identify what your concentrated values are. So this is 20 milliliters of 0.5 molar stock solution. So this is going to be your V1. So your V1 is going to be 20 milliliters. And then your concentration C1 is going to be 0.5 molar. Now the C1 doesn't really have to be only in the molarities. You may see that in the concentration, in the percentage, or in mass volume percentage as well, or even the molarity. Okay, so now I know my V1 and C1. Okay, so we're trying to figure out what the concentration of this diluted solution is going to be. So we have to figure out the C2. So we'll just write that there. And what's going to be the V2 now? Well, the question is saying you adding 100 milliliters of water to 20 milliliters of stock solution. So you already have 20 milliliters present in the stock solution. So assuming these volumes are additive, and you can more or less assume so when you're doing these problems, that when you're adding two different volumes of solutions, assume they are additives. So this 100 milliliters of water plus you already have 20 milliliters of stock solution is going to make a total of 120 milliliters of total volume. So that's one thing you have to really make sure. A lot of times students do make mistakes and they will use 100 milliliters here instead of 120 milliliters. Okay, so now we got everything here. So just go and set it up. So we want to use C1 V1 equals C2 V2. And we're trying to figure out the C2. So I'm going to divide both sides by V2. So it's going to be C1 V1 over V2. So my C1 is 0.5 molar. Then your V1 is going to be 20 milliliters. And then divide that by V2, which is going to be 120 milliliters. Okay, so the units for the volume is going to cancel out, and all you're really going to have left out is the units in molarity, and that's what you're really looking for. So I got 0.5 times 20 and divide that by 120, so that's going to give you about 0.083. So that's going to be your final concentration of the diluted solution once you add 100 milliliters of water in this stock solution. Okay, all right, let's do another one. All right, so it's going to be a better idea to pause the session and probably attempt to do this problem on your own and see if it matches with what I did. Okay, so assuming you did the pause and you did the problem on your own, and let's see if it matches with my work. So we are told we have well, how much water should be added to dilute 100 milliliters of stock solution of 6% sugar by mass. Okay, so the concentration here is given by mass to 2% solution. Okay, well, we know the information about the stock solution here, so we got the V1 to be 80 milliliters, and then we got the concentration C1 to be 6%. Okay, and we need to reduce this to 2%. Okay, so your C2 needs to be 2%, and the question is asking how much water should be added, so you got to be really careful with the wording of the question. It's not really asking you what's going to be the total volume of the diluted solution at the end of the day, but rather how much water is going to be added. But then remember, there's really not any way to calculate the water directly, the amount of water directly, but rather you have to figure out what's going to be the total volume of this diluted solution using the dilution formula. So we can certainly go ahead and calculate the volume too, which is going to be the total volume. And once we have the total volume, we can subtract the total volume from the stock solution volume to figure out how much water was added in there. Okay, so let's go ahead and use this formula. So I got C1 V1 equals to C2 V2, and we're trying to figure out V2 in this case, so leave V2 on one side, and then we got C1 V1 divided by C2. Okay, so let's go and plug in numbers now. So we got 6% for C1. Your volume is going to be 80 milliliters. Okay, and then divide that by the C2, which is 2%. Okay, so your total volume, which is going to be V2 here, obviously your percentage cancels out, and then that's just going to be 80 times 6 divided by 2, so that's 3 times 8, that's 240 milliliters. So that's going to be the total volume of the solution, of the diluted solution that has been made. Now the question is asking how much water, all right? So if you're doing a multiple choice question and you will have an answer option that's saying 240 milliliters, but that's going to be incorrect because it's asking for how much water is added, and 80 milliliters of the stock solution was already there. So the amount of water that was added can be figured out by doing 240 minus 80. All right, so that's going to be about 160 milliliters of water that's going to be added in this particular case. Okay, so hopefully this was helpful. Let me try one more question that's going to be a little more complicated than the above two. All right, so it says a stock solution of NaCl, sodium chloride, is prepared by dissolving 20 grams of NaCl in enough water to make 200 milliliters of solution, and then to the 50 milliliters of stock solution. Okay, so what's going to be your stock solution? Your stock solution is going to be the one that's going to be made by adding 20 grams of sodium chloride in a solution of 200 milliliters. To that stock solution, we add 80 milliliters of water, okay? And then we're trying to figure out what's the molarity going to be for the final diluted solution. Okay, so if I try to work it backward, and it's going to be a really good idea if you can pause the session here and try to work it out on your own and see if it matches with what I did here. So we got the stock solution, and I don't know the concentration of the stock solution. So let's say C1, we don't know that yet, okay? And we are using only 50 milliliters of stock solution. So I know the volume is going to be 50 milliliters. And then it's saying 80 milliliters of water was added to that stock solution. So that means the volume V2 of your diluted solution is going to be 80 plus 50, because assuming the volumes are additives there. So then it's going to be 130 milliliters. Okay, and we're trying to figure out the molarity of the final diluted solution, which technically means the concentration. So what you really have to do, the C1 needs to be found in the molarities. We don't know that yet. And once you know the C1, it should not be hard to figure out the C2. But the difficult part here is going to be how you're going to find the C1. And to get the C1, you're going to have to rely on the information that's given on the first line of this question. Okay, so it says you have 20 grams of NaCl. So remember, your C1 can be calculated by doing moles of NaCl divided by liters of the solution. Okay, we know the liters of solution. Well, technically, we were told we have 200 milliliters of the solution in the beginning. Make sure to convert the 200 milliliters to liters. So if I do that, that's just going to be a conversion factor being used here. So it's going to be 1 liters is about 1,000 milliliters. So it's going to be 0.2 liters of the solution there. Okay, and then we're going to go ahead and figure out the moles of NaCl, because we are given the 20 grams of NaCl. So it's going to be 20.0 grams of NaCl. And then how do you convert the grams to moles? Well, that goes back to the moles concept. If you have a hard time calculating the moles from the grams, you may want to watch the other video where I have explained the mole concept. Well, technically you will be needing the molar mass, so I would have to have moles of NaCl on the top and grams of NaCl on the bottom. So when you calculate the molar mass of NaCl, you add up the atomic mass of sodium and add the atomic mass of chlorine. So when I did this calculation, it came out to be 58.45 roughly. Okay, so that when he set it up like this, the grams gonna cancel out, and now I got 20 divided by 58.45, and that's gonna be 0.342. Let's keep 3 sig figs for right now. Okay, so then to find the concentration C1, which is the molarity, I would do 0.342 moles of NaCl and divide that by 0.2 liters. So that's going to be 1.71 molar. Okay, so now we know the C1, so I can go back and plug the C1 in there. So it's going to be 1.71. From here, it should not be hard to figure out what the C2 is going to be. So now we can go ahead and use this dilution formula. So it's going to be C1 V1 equals to C2 V2. And when I rearrange it to find the C2, I would have to do C1 V1 over V2. And you can, if you want, you can go ahead and plug in the numbers and solve your way as well. It doesn't really matter how you do the mathematical portion as long as you do it right. So your C1 is going to be 1.71 milliliters. Your V1 is 50 milliliters. And then your V2 together is going to be 130 milliliters. So keep in mind, even though you made a total of 200 milliliters of solutions in the beginning, you're only using 50 milliliters of that to dilute it. Okay, so when you do this math here, so let's see, we got 1.71 times 50 and divide that by 130. So it's going to be 0.66 molar as your final concentration at the end of the day. Okay, so that's how you guys going to be doing the how you guys going to be making the solutions, and once you make the solutions in the lab, you guys going to be performing a series of dilutions, and you're not going to be using the whole solution that you made. You only use a small amount of solution that you make, and you just move along as we go here. All right, if you have any questions on any of these, please feel free to leave any comments in the section below.